Now in the next sequence we are having a third graph, that is distance time graph for a body at rest. We know that if a body is at rest, that means we can't see the object is moving. And if the object is not moving, the question seems to be quite interesting, that if the object is not moving, how we are going to draw the distance time graph for that. But we can draw the distance time graph for such a body also by taking a table. So just have a look at the table and that will be very quite easier for you to learn how we will draw the graph. At t second, that means at 0, at the beginning, when you have seen an object, it was at a distance of 100 meters from yourself. After 10 seconds, you are standing at the same place and you have watched that the object is lying on the same distance, 100 meter. In the next 10 minutes, that means in 20 seconds, 100. In next 10 seconds, that is 30 seconds, 100. After 40 seconds, it's at 100. After 50 seconds, it is at 100. After 60 seconds, it is at 100. That means it is at a distance of 100 meters from your place. Either you have started watching it from the very beginning or till 1 hour. It has not changed its position. So here, how we are going to draw the graph of the same objects? We have taken, just plot the points very clearly, and these points will be 10, 20, 30, 40, 50 and 60, and this is your 100 meters. At 0, you have seen it is at 100 meters. At 10 seconds, it is at 100 meter. At 20 seconds, it is at 100 meter. At 30 seconds, it's at 100 meter. At 40 seconds, it is at 100 meter. At 50 seconds, it is at 100 meter. And at last, after 1 hour, it is still at 100 meters. So, the graph for a stationary body or a body at rest is a straight line parallel to the time axis. So now if the question comes, what is the distance time graph for a body at rest, or what is the nature of the distance time graph for a body at rest, you will write the answer. It is a line parallel to, it is a straight line parallel to the time axis. So it might be a question that what are the 3 things that you can find out from a given graph. So just have a look at this graph, and now I'm going to tell you the 3 particular things which you can find out from a given graph. Suppose that this distance time graph is given to you. The very first thing that you can find out from this graph is nature of the graph. What you can find out from here? Nature of the graph. That it is a straight line or a curved line or a straight line parallel to time axis. So you can find out the nature of motion. From a given distance time graph, you can find out the nature of graph. Second thing, what you can find out from there, you can find the slope or speed from a given distance time graph. You can find out slope or speed from a given distance time graph. Third thing, which is very important, which is quite interesting to you all also and very easy to determine from a given graph, that is position of an object at any instant. How can you find out the position of an object at any instant? When you will draw this graph on a graph paper, in between 100 to 200 there will be 10 minute columns, and in between 0 to 50 there will be 10 minute columns. So if I'll ask you at 25th second what will be the position of the particular object, you can tell me that at 25th second the position of the object will be 50 meters from the beginning. Similarly, you can find out the instantaneous position of any object. Suppose that somebody asks about this position, you will simply draw a perpendicular on the time axis, and corresponding to that point you will draw a perpendicular on the distance axis, that means y-axis also, and you can find out the distance of particular point to be 250. And remember that you can find out the 3 things: the nature, secondly slope or speed, and the third one instantaneous position of an object from this thing. Hope the topic is very clear to you, that how you are going to draw the distance time graph for uniform speed, non-uniform speed, and the third one, stationary body or body at rest. Thank you.